standard, I'll be taking the second chapter, that is motion in one dimension. Correct? Now in this lesson you are going to learn about scalar and vector quantities, about rest and motion, followed by distance and displacement, speed and velocity, and towards the end acceleration. Okay, so let's begin with the first term, that is scalar and vector quantities. Okay, what is a scalar and a vector quantity? Before that, you'll need to know the meaning of a physical quantity. What is a physical quantity? So it is a quantity which can be measured. Now they are broadly classified as scalars and vectors. Now scalar quantities are those quantities which will have magnitude only. That means you can measure them provided you know the magnitude. Now for example, distance. In order to measure distance, we should know, you need a measuring tape and you need to know a fixed length. For example, if I say distance of this marker is 10 centimeters. Okay, so I have a magnitude here and I have a unit for it. The moment you look at the unit, you know I'm talking about a certain length. So it is a scalar quantity. No other information is being given. So such a quantity is called scalar quantity. Next is vector quantity. What is a vector quantity? Now suppose along with the magnitude, direction also is given, then you call such a quantity as a vector quantity. For example, if I say that the speed of wind is 120 kilometers per hour, but if I don't mention the speed, if I don't mention the direction in which the wind is blowing, that means I'm not giving the proper information. So it is very important in certain physical quantities to mention, along with the magnitude, you need to mention the direction as well. Such quantities are called vector quantities. Now we come back to scalar quantities. So for scalar quantities, only magnitude is needed and we can add scalar quantities just like normal, using normal arithmetic. You can add, you can subtract, multiply, divide. Whereas in case of vector quantities, you have special vector addition methods which are to be followed, and vectors are represented using alphabets. Like for example, displacement is a vector quantity, and suppose you use S, you need to put an arrow on top, so you know that you're talking about a vector quantity. Whereas here for distance, if you just write it as S, that means without any arrow, that means we're talking about a scalar quantity. Okay, that is the difference. Now examples of scalar quantities. Now distance is one example, then speed, work, energy, power, temperature. These are some of the examples of scalar quantities, wherein you don't need a direction in which these quantities are being measured. Whereas in case of vector, examples of vector quantities will be displacement, velocity, momentum, force, acceleration. These are some of the examples of vector quantities. Now in these examples which I have mentioned, you need to specify the direction in which these objects, when they are being measured, you need to know the direction. Okay, so this was about scalar and vector quantities. Next we move on to rest and the concept of rest and motion. start with rest and motion. Now, remember that in the universe, there is nothing which is at absolute rest. All the things are in fact moving. Okay, now rest and motion, these are in fact relative quantities. Okay, they are relative to each other. That means it depends from person to person. Like when an object which is at rest for one person may not be at rest for the other person. Okay, like for example, there are two people sitting in a train facing each other. So for the first person, the second person will be at rest. But when the train is, even though the train is moving, for the first person, the second opposite person is at rest. But for an observer who is outside, I mean on the platform, if he sees both the people in the moving train, for that observer, both the people are at rest. Okay, so that is the concept of rest. And motion is with respect to one person. When the other person is moving, we say that the second person is in motion. So that is the reason we say it is something which is relative. Now this board, for example, this board which is here, for me it is at rest. But for an observer who is in space, since the earth is continuously rotating and revolving, this board will not be at rest. Instead it will be in motion. So it depends from with respect to the observer, right? Okay, now we talk about the next concept is distance and displacement. Okay, how are they different? What is the difference between distance and displacement? So this is point A, and you have another point B. In order to from point A, in order to reach point B, there are different directions which can be followed, right? So I can follow one. Either I can go straight to reach point B. I can use a way like this. I reach point B. I can use a way like this, then reach point B. I can take a long route and then come to point B. Alright. So if you look at these four different distances, the red dotted line to reach A and B is the shortest line, and it will take less time. So this shortest distance is called as displacement. So in order to, from the starting point to the end point, the shortest distance that is actually used is called as a displacement. Whereas all other paths which are being used, these are called as distances. So distance is nothing but the total length that is being covered to reach its destination. Okay, whereas displacement is the shortest path that is being used to reach its destination. Now remember, displacement can be zero, but distance cannot be zero. I'll give you an example. Suppose you have point P, you have point Q. You have to start from point P, go to point Q and then come back. Okay. Go to point, from P you go to Q and then come back to its original position, that is point P. Now in this case, what is the displacement and what is the distance? So distance will be, so you have to travel from P to Q. So this distance, suppose this is 5 meters. Suppose this is 5 meters, and then you have to come back to reach point P. So 5 to go and 5 meters to come back, so it becomes 10 meters. So 10 meters is the distance. So distance is 10 meters. Whereas displacement, what will be the displacement? Whereas displacement in this case will be 0. Now what is the reason? Because as per the definition of displacement, it is the shortest distance taken from the starting and the end point. In this case, starting point is P and end point is P itself, because after covering all this distance, the person is coming back to its original position. So displacement is 0. Okay, and displacement is, and it is very important to mention the it is a vector quantity, so it is very important to mention the direction in case of displacement. Whereas in case of distance, it is a scalar quantity, because direction is not important in this case, right? So after this, once we know distance and displacement, the next uh, part is about speed and velocity. The next concept is speed and velocity. Okay, what is speed? Now speed is nothing but the rate of change of distance with respect to time. It is denoted by u or v, small u or v, small v. Okay, so I can write speed is equal to distance upon time. How much time is taken to cover a particular distance is speed. So what will be the unit of speed? You know, the distance of the unit of distance is the SI unit is meters, and SI unit of time is seconds per second. So you can write it as unit of speed is meters per, which is equal to meters per second. Speed, since direction is not important, it is a scalar quantity. Whereas velocity, what is velocity? Velocity is the rate of change of distance in a particular direction. So you can write velocity as, you can say it as displacement on time, ratio of displacement upon time. So again, unit of displacement is meters, SI unit is meters, and time is in seconds. So the unit of velocity is again meters per second, but it's very important to mention the direction in case of velocity, whereas for speed, direction is not important. Now under speed you have what is called as uniform speed. Now what is uniform speed? Uniform speed is nothing but when an object covers equal distances in equal interval of time, you call the speed as uniform speed. For example, there is a frictionless surface and there is a ball which is thrown, allowed to roll. You find that ball will cover, since there is no friction on the table, you find equal distances will be covered by that ball in equal interval of time. So such speed is called as uniform speed. Then you have non-uniform speed. What is non-uniform speed? When an object covers unequal distances in equal interval of time, you call the speed as non-uniform speed. Example would be a vehicle moving on a crowded, a busy road, or you can say a vehicle which is moving over a speed breaker. Every time you find the distance covered will not be the same for per second. So such a speed is called as non-uniform speed. Then you have instantaneous speed. Okay, what is instantaneous speed? Now, instantaneous speed is nothing but the speed of an object at a particular instant when the time interval is very short. Like within a fraction of a second, you just want to know what is the speed of a vehicle, of a moving vehicle. So, such a speed is called as instantaneous speed. We, for example, when you are in the car traveling, you want to know the speed of the car. You just look at the car speedometer, so you come to know at that instant, you come to know what is the speed of the at which the vehicle is moving. So that is instantaneous speed. Next is average speed. Okay, average speed is the total distance covered and the total time taken to cover that distance. So you can say it is the total distance covered and the total time taken to cover that distance is called as average speed. Now same with when we talk about velocity, you have uniform velocity as when you have equal displacements in equal interval of time in a particular direction gives you uniform velocity. Non-uniform velocity will be when unequal distances are being covered in equal interval of time in a particular direction gives you non-uniform velocity. Okay, next is instantaneous velocity. Instantaneous velocity is nothing but the velocity of the moving vehicle at a particular instant when it is moving in a particular direction. And towards the end it is average velocity. Average velocity is the total ratio of total displacement and total time taken to complete the journey. It's called as average velocity. Okay. So the last concept here is about acceleration. Okay, so acceleration and deceleration. Acceleration is nothing but the rate of change of velocity per unit time. So it is denoted by A with an arrow since it's a vector quantity. So it is the rate of change of velocities. When velocity changes from one particular value, suppose there's a car moving at a speed of 50 kilometers per hour, it is increasing its velocity from 50, it is increasing to 70 kilometers per hour within 5 seconds. Okay, so you suppose u is the initial velocity, which is 50 kilometers per hour, and you have the final velocity v as 70 kilometers per hour, and the time taken for this change from 50 to for it to change it to 70, time is 5 minutes, within 5 minutes. So acceleration is the rate of change of velocity. So it will be 70 minus 50 difference upon t. You can write it as 70 minus 50 divided by 5, 5 which is 20 upon 5. Now 5 is minutes, you need to convert it into hours by dividing it by 60. So accordingly you get the value of acceleration. Now what is the unit? The unit of velocity is meters per second and unit of time is seconds. So the unit of acceleration is equal to meters per second square. It is a vector quantity. Now suppose instead of velocity increasing, suppose the object's velocity is decreasing. A car which is already traveling at a speed of 120 kilometers per hour, suddenly it applies brakes. So its initial velocity will be different than the final velocity. So if you take the difference, you find you get a negative sign. If you substitute the values, you get a negative from 120 kilometers. After applying brake, the car is stopping. So final velocity is 0. So in this case, you have acceleration will be 0 minus 120 in time 5 minutes. In time 5 minutes. So then after doing the conversion, you find you get a negative sign. So whenever acceleration decreases, you find it is called as deceleration or retardation. Okay. So these were the concepts of acceleration and deceleration, or the other term that is used is retardation. And towards the end, I'll be telling you all about acceleration due to gravity. Now, it is denoted by g. Acceleration due to gravity is denoted by g. It applies to objects which are freely falling from a certain height. So it is due to the influence of, you can say g, it has got mass, so due to the influence of gravity, the object will obviously fall down. So that gravity which is pulling the object towards the earth, that is called as acceleration due to gravity. It has got a fixed value on the surface of the earth. Its value is 9.8 meters per second square. And you find that as you go higher and higher, the value of g decreases. As you go under the surface of the earth, you find the value of g decreases. And on the earth, the value of g will be, it varies on the earth. If you are at the poles, you find the value of g will be maximum on either poles, and at the equator you find it will be minimum when you are comparing. Okay. So today we have in this lesson, motion in one dimension, you all have learned about the different terms related to speed, velocity, acceleration, deceleration. In the next topic, you are going to learn about graphical representation of motion.